everybody. Today we are going to be talking about one-step subtraction equations. We're on lesson 6.3. So working on writing and solving equations, dealing with subtraction. Now, the vocabulary that we will be talking about is the addition property of equality. So this is a way that we can solve subtraction problems. All right, so when we are writing subtraction problems, we do the exact same thing that we did when we were doing addition problems, addition equations. Same 3 steps. Picking out the important information, substituting in a variable and defining what it would be, and then writing it as an equation with an equal sign and a variable. So if we were doing the problem here, Carolyn gave Everly 8 beads and was left with 37 beads. We're going to write a subtraction equation that can be used to determine the total number. So first thing we need to do, pick out the important words. Total number of beads minus the number of beads given away equals the number remaining. We're going to define the variable, and we're going to use T to represent total number of beads. Now we can write the equation. T, meaning the total number, minus 8 equals 37. So that's how we would write this equation here. So let's go ahead and try this with example 1. The oldest person to travel in space was John Glenn. The youngest person to fly in space was only 25 years old. At 25 years old, this is 52 years less than John Glenn's age. So we're going to write the equation here, picking out the important information. We know that 52 years less than John Glenn's age is the youngest person's age. We're going to define the variable. Since we're trying to find the age of John Glenn, we're going to use A to represent his age. So what we would start with is A, right, for John Glenn's age, minus 52 years, right, because we see 52 years less than, equals the youngest person, which was 25. So that's how we would write this equation here. Let's go ahead and try the check. As always, pause here and see if you can do it on your own. It says an ebook costs $14.95. This is $7.55 less than the cost of the hardback version of the same book. Write a subtraction equation that can be used to find the cost of the hardback book. So pause here, see if you can try it. Now, I am going to use the variable h to represent the cost of the hardback book. I'm starting with my variable here. I am subtracting how much less than a hardback book it would be, $7.55, to get the total of $14.95. So this would be our equation that we would write to find the cost of the hardbacked book. Now, let's actually talk about solving. We've figured out how to write it. Now let's solve it. So once again, we can use substitution models or properties of mathematics to solve subtraction equations. Now, if we're trying to find the value of x in this situation, we're going to use a bar diagram. Here's our equation. X minus 15 equals 11. So x would represent the total cost. We're subtracting 15 to get to 11. So to find the total of x, we would simply add together the 15 plus 11 and find that x equals 26. Another way to do this is use the addition property of equality. If we are missing the first value in a subtraction problem, we can simply add the remaining 2 values to figure out what the variable equals. So what that means is I'm going to add 6. I'm going to do the opposite of subtracting 6, which is adding 6 to both sides. This then gives me only n on my variable side and gives me 13 on the other side, so n would equal 13. So remember that whole inverse operations that we talked about. I'm on page 354. Let's go ahead and try example 2. Now, here we have 32 equals x minus 7. So once again, remember we add the constant that's on the variable side to get the variable by itself. If I add over here, I have to add over here. When I'm adding 7, I would get 39 equals x. We can then check our solution by plugging in the number back in for the variable. So does it work? Yes. We're going to do the same kind of problem here. So remember, you can pause here and try it on your own and then resume. So we'll use our addition property of equality here to add 731 to both sides. This leaves me just x on one side. That would be a 10 and 5, 7. So 2,750 would equal x. There we go. All right, so let's try one last problem here. We're subtracting once again. This time we have some mixed numbers with unlike denominators. Remember, whenever we're adding or subtracting fractions, we need to have like denominators. So you're going to change this 2/3 into 4/6. Then we add 13 and 4/6 to both sides, and you would get 15 and 5/6 equals m. Go ahead, pause here, try your check. So when we do this, right, we first need to come up with common denominators. That means I'm going to change my fractions to have a least common denominator of 20. Right? So if I'm doing that here, 4 times 5 is 20, so 3 times 5 is 15. 5 times 4 is 20, so 2 times 4 is 8. We are then adding 15/20ths to both sides to get p by itself. Let's see if I can get a little closer. There we go. 15/20ths over here. If I do that, I'm going to add 15 and 8. All right, so 15 plus 8 would give me 23. But remember then, we're going to take that 23/20ths and pull out 1 to leave me with 3/20ths and add a 1 here, which would be 5 and 3/20ths. Now, can we simplify here? No, that's as simple as it can be. And there would be our solution. So let's take a look at our apply problem. As usual, please email me your answer when you've got it. Tyson has $302.87 in his savings account after he withdrew money to go shopping. He spent the amounts shown and he had $18.25 remaining. Write an equation to find how much money Tyson originally had in his savings account. All right, so as always, please make sure if you try this apply problem to email me your solution. I'd love to know what you came up with, and complete your work on McGraw-Hill online. Make sure to check the daily slide to find out what the homework is. And I hope you have a great day. We will see you later.